Algebra 2, regions, common core. Deriving the equation of a parabola given a focus and directrix. So in our previous video, we covered what a focus and directrix were. They are basically the two things that create the parabola. Every point on the parabola, or a parabola, is all of the points that are equidistant to a focus and directrix. And we're going to use that concept to help us find the equation of the parabola here now. And we started in the, well, we didn't start, but in the last video, we did a question similar to this, just flipping back, to where we had to set up an expression for the distance between a given point in the directrix and that given point in the focus, and we knew they were equidistant. And that helped us find a missing part of the point. Well, we're going to do kind of the same thing here, that we have a focus, and in this example, it's 4, 5. And we have a directrix, y equals -5. But we don't have a point. So we need to think of a point as all of the points, x, y. We're going to use point P and x comma y to represent every point on this parabola. So every point on the parabola is made up of x comma y. And we're going to use the fact that all of these points are equidistant to these two things. So we always start off by figuring out the distance between the point and the directrix first, much like we did here, the distance between the point and the directrix. We begin with that because that's a vertical line. And to get the distance between a point and directrix, we could take the point's y value and minus the directrix y value. And in the last video, that came out to be like 3 minus -2, and we got a distance of 5. But the problem here is we don't have a specific point. We're just kind of saying, all right, this is the point, and it's x, y. So how do I know the distance between this and the directrix if I don't know the coordinate here? Well, we don't. So what we have to do is we have to create an expression for the distance, not the exact length. Because remember, this represents every point. And every point on the parabola, or half of the points on the parabola, have different distances to the directrix. Like a point here is this distance, a point here is further, a point up here is even further from the directrix. So I can't have a number like 5 because it depends on what the point is. But what we can do is we can take our point's y value, which for this is just y, minus our directrix y value, -5. And if we simplify this, we get y plus 5. And so this is an expression to represent the distance between the parabola and the directrix. Every point on the parabola is whatever its y value is plus 5 away from the directrix. And if you think about it, it makes sense because like this point here, let's say it's 3 above the x-axis. And so its y value would be 3. But its distance to here, you have to add another 5 to it because this is y equals -5. This is 5 further below the x-axis. So whatever your y value is, that's going to give you the distance here. Well, if we add 5 to that, that's going to give us the distance here. So this might make sense. If it doesn't, that's really okay too. Just know how to get it. Take your y value y and basically minus your directrix and get an expression there. And then the distance between the point and the focus, well, that also has to be y plus 5. But that's not just a simple vertical or horizontal line. That could be a horizontal line. It could be a vertical, but it could be, a slanted here. It could be slanted here. We don't know. So what we have to do for the distance between the point and the focus is the distance formula. And we saw that again in the previous example. We did the distance formula. That's what we're going to have to do here also. But we set it equal to y plus 5 because we know it has to equal that distance. So the same thing here. That this distance is y plus 5. Well, same thing with this distance. This distance is y plus 5. And so I could set my distance formula equal to that. And the distance formula, the giant square root. And we subtract the x's squared plus subtract the y's squared. Now the x's here, well, my point is just xy. So my x value for that is just x, and my y value for that is just y. But I can use those to subtract from my focus points. So subtract 4 for the x and subtract 5 is the y's. And so what I see is I see a lot of expressions, a lot of binomial expressions. That's very normal. To get rid of this giant square root, I could square both sides, and what that gives me is y plus 5 squared equals x minus 4 squared, fix that 4, plus y minus 5 squared. And what we have is a bunch of binomial squares, and this is a skill that we see a lot in this course, so you have to be able to do this pretty good. It's you could think of it as times itself and do FOIL, but some of us are able to do kind of like a mental shortcut, square the front times each other doubled, 10y, and square the back. But if you don't like that mental shortcut, you could write y plus 5 times y plus 5 and do your distribution. You can do a tabular method, however you like to multiply. This one's going to be x squared, if I square the front times each other doubled, is negative 8x. And square the back is plus 16. It's always plus on the back end because anything squared is positive. Plus y squared times each other doubled is negative 10y plus 25. Now remember what we're trying to do here is we're trying to get the equation of a parabola. And the equation of a parabola looks like y equals ax squared plus bx plus c. So I want y equals on the left side. I have a lot of other stuff there. And also notice that you have x squareds and y squareds. We don't see that in a parabola, but the nice thing that happens here is we have a y squared here, but we also have another one here, and they cancel each other out. So now x is the only variable squared. X and y can't both be squared for a parabola, so it works out that one of them cancels out there. But again, I only want y over here. So I'm going to get my y terms to that side. So I'm going to add 10y to move this piece to the other side because I want the y's over there. And I'm also going to minus 25 to get this to the other side because it's not y, and I want to move that to the other side. I actually have a 25 over here that they can cancel out. That doesn't always happen. Sometimes you have to combine numbers. So let me rewrite this a little bit here. We are now looking at 20y equals x squared minus 8x. And I move that over. That canceled. So plus 16. And then lastly, I don't want 20y. I want just y. So I'm going to divide everything by 20. And it's very common to get fractions for these answers. You're not going to see many nice, simple whole number parabolas that have a whole number focus, whole number directrix, whole number ABC. It doesn't really work out that way. So I'm going to write this as this x squared over 20. I'm going to write it as 1 over 20 x squared because there's a 1 in front of that. And minus, I could simplify these, divide them both by 4. So that's going to be 2/5 x. And again, I can divide both of these by 4, so that's plus 4/5. And this is my final answer. This is the equation of the parabola that has that focus and that directrix. It is equidistant. All these points on here are equidistant to y equals -5, and the focus 4, 5. So this is one of the more complicated things I think we've done so far this year, and you want to start off by py minus dy to get the distance between the point and the directrix, and it's going to be an expression most of the time. Y plus 5, y minus 2, things like that. Set your distance formula with that and your focus equal to that expression. Square both sides. A lot of binomial squared algebra in there, combining like terms, moving things around, and you'll end up with your final answer as a parabola. All right, that's it for now. See ya.